This is a senior design project scheduled to begin fall 2022. It's about representing music with different colors. So there are relationships between notes and colors. The most obvious one is that notes have frequencies. In fact, a lot of notes are just, I know they're C sharp and D flat and all that kind of stuff, but they're really a frequency underneath it all. Well, colors are too. If you've ever had physics, you know that colors are just different frequencies of light. So really, there's an obvious relationship between notes and colors, and it can be um, based on the frequencies. Now, what I'm going to suggest is that there can be different types of mappings. So you'll want to create different mappings between notes and colors, not just one mapping. There are people actually who see color when they hear music and sound. Usually they're called, let's see, the condition is called chromesthesia. A lot of times you'll hear these people called synesthetes. I actually know a synesthete, and he didn't even know he was a synesthete. He thought everybody saw colors when they heard music. So chromesthesia, or sound to color synesthesia, is a type of synesthesia. It's just a condition that some people have. I actually sometimes wish I had it, but I don't. So what I'd like for you to do is consider the simple relationship of music note frequency to color frequency as level 0. So we're going to call this level 0. It's the simplest, most trivial relationship we can find, but it's still an important one to explore. A level 0 is going to be for only monophonic melodies. So what we have to do is just make sure that whoever's using the software knows that level 0 is for just a single line melody. So fundamentally, color has a frequency. Sounds are frequencies. So the very first thing to explore is mapping notes to colors. I would suggest having some sort of lookup table, and then there can be different schemes, all easily selectable, and you're going to have some sort of a MySQL database. So I would store the different schemes into a MySQL database, so you can have and I would suggest a bunch of different schemes so that people can experiment. I would not, now initially it's okay if you just sort of phony them in there, but you are going to have to do some sort of research to kind of figure out, like maybe synesthetes, maybe there's some sort of a normal set of colors they see when they hear different notes. I'm not really sure, but you're going to have to go ahead and do some research to kind of back up what you're doing. And here again, this last bullet point, see if these people who have these skills, are they consistent, or are there trends or whatever, and just kind of know maybe what they see. Now the technologies you're going to use, this sounds like me in processes, right? So all programs are going to be web-based. Well, it's really just going to be one program. It's going to be web-based. I will tell you that getting the microphone input might be a little difficult, but probably not too bad. That's probably going to be the only difficult thing you're going to have to do. I would like very much, and this is a requirement, the logic code has to be abstracted. All of it's going to be written in JavaScript. And what I want to do is to be able to take your code and drop it into other contexts. So this has to be reusable code that doesn't have a bunch of dependencies that so I have to use it within your program or whatever. I have to be able to take out your code, like the code that translates, say, a note to a color, or a note frequency to a color, and really put it into any of my programs. I'm going to ask you to use a MERN stack. M actually is not going to stand for MongoDB. It's going to stand for MySQL. I actually could be convinced, since this is actually a pretty straightforward program, to go with HTML, CSS, and Bootstrap. I would be okay if you decided to do that. That actually will probably keep it quite simple. You definitely have to use Bootstrap so that it's responsive. And these next two bullet points, the database is going to be a local MySQL, which is all going to be hosted on DigitalOcean. And we're not going to need a very beefy server or a beefy account. I mean, basically, almost the bottom tier DigitalOcean should be able to handle everything. I could go up one tier or whatever, and I'm the sponsor, so I'll pay for all that. The only library I'm going to suggest that you use is a Fourier transform library. You're definitely going to need Fourier transform to do Fourier transforms, because what Fourier transforms are going to do is convert the sound from the microphone input to actual frequency numbers. So it would be very difficult to write that on your own. So I mean, you could do it for sure, especially if you have differential equations. But I would suggest you use a library for that. I'm going to ask you, though, not to use any other libraries, just because I know students who can't tell time without a library. So I don't want. I would rather you focus on what we're trying to do. We're trying to explore this relationship of music to color. And don't get hung up on a bunch of libraries, because if you do, then I'm not going to be able to go in there and use what you've written. Also, it's going to defeat the whole thing about, your code is going to be abstracted. So I'm going to ask you to only use the Fourier transform library. Now, there is a built-in sound thing in JavaScript. I have a website I did for Dr. Ayers in the music department called microtonality.net. And you can actually just look at that, or I can give you the code directly. And it shows you how to use the built-in JavaScript stuff to go ahead and play notes and music in a web app. So then there are other. So we've talked about this level 0 relationship. But then there are relative relationships within the melody. Like maybe I went up 5 sequential notes. So now I've got relationships with internodal relationships, and those should almost have more effect than the level 0. This is level 1. These internote relationships, and I actually with the level 0, it's easy. So you get frequencies. You have some sort of frequency equivalence, right? Well, level 1, I don't know. You're going to have to do some research and figure out good ways to do that. I also want you to be able to load in different schemes so that it's not just a single scheme, but the users can decide, and they can select and experiment around. So here again, this is also still just for monophonic melodies. So anyway, as I said here, this last bullet point, you need to make sure you can load and save from storage. And the last thing is level 3. And level 3 is going to be for polyphonic or multi-voice music. You can factor level 0 in if you want. I would definitely factor level 1 in somehow. But the addition will be adding relationships between voices. So like, let's say you have a minor key, you'll know that there's a minor key or a minor chord, and that will have one color. Or if you have like a major 7 or something, that'll have another chord. So you're definitely going to have to do some research there, and we can work together on sort of brainstorming that. So your deliverables are one JavaScript web-based program. So really, you're just giving me one program, which is going to be web-based, which I'm going to provide the hosting for. We'll figure out some sort of a domain name that works. Sounds cool. Your code has got to be totally abstracted so that I can use it in other contexts. So I don't want to copy one of your functions and have it rely on 13 other functions. That's not the way it needs. It needs to be just that function just works without a bunch of dependency functions. You have to let the user be able to select level 0, level 1, or level 2. All three have to be supported with some sort of a selector. Each level has schemas that can be loaded in, which, like, take for level 0, that's going to be, oh, well, you know, a C# is this color, D is going to be this color, and so forth. For level 1, it'll be, well, what does it mean when I do 5 consecutive ascending notes or something, you know? The microphone will provide the input. I may actually at some point maybe want to support say loading an MP3 file, but let's just for right now leave it at microphone. If the functions are abstracted correctly and well enough, then it'd be really easy to add MP3 input or wave input or whatever. And you're going to have to do some excellent research, because you can't just come up with your own conclusions and expect people to believe you. You actually need to do some research and be able to explain, well, here's why we made this decision.